Hi folks, this is the new setup. We've got Tesla turbine there, we've got snap-on oscilloscope which is currently monitoring the analog input from the pickup, the magnetic pickup there. This is what's called a differential amplifier, which is a comparator circuit. So it takes the input of the analog magnetic pickup as an AC waveform, and it will output it. It will digitally change it in this unit to a square wave, and then that gets fed to here. Both the pickup and the differential amplifier, the comparator circuit, both of them have got this same screen cable. It's a 2-core cable with a screen, and that feeds into the back of the Logitech Electronics tachometer, so we can monitor either the digital or the analog signal on the scope, and then we get the final readout on there. So I've got 6 bar in the tank, so I'm just going to do this quick test and capture the waveform. We're on a 10 millisecond time base. Here we go. Right, I'm going to take the air away now to let the compressor fill back up a bit. I'm just going to show you what the difference is between capturing AC and DC. So I'm just going to change that to this one. Actually, get it right to that one. So this should be digital. I'll just change the time base a minute to just change it on to 2 seconds for a minute. Probably did pick the right one the first time. There we go. So if I change it, that's on 1 millisecond, so 1 second. If I put it on 500 milliseconds, you get quite a clear square wave. Put that onto 100 milliseconds, be even clearer. But what I'm going to do is I'm going to put that back to, I'll put on 5 milliseconds, so I won't be able to spin it that fast. Spin it! If you look at the tachometer, I can spin it nearly up to 3000. So if I blow some air into that now, so yeah, you can see how it's working. And what I've done is I've gone back to Logitech Electronics and asked them another bunch of stuff about their other sensors and stuff. They deal with like temperature sensors, and they might be able to do something with air velocity. So I'm inquiring about that. I'm also inquiring about converting this so it'll output the information to a PC. There's also the inputs on the back of this for a second tachometer input, and just with a flick switch you can flick between the two channels. My idea is to get that so it will output both channels straight to a PC, and then I can change the appearance and create an animated analog looking tachometer that goes up to 250,000 RPM, which I think would be pretty cool, and you can mess around with the graphics and tart it up, make it look something like from some futuristic car. Yeah, so got that to come. I've got a second differential amplifier, and already I've got the second pickup. I wish you could display it on this screen simultaneously, but that's not doable. So I'll have to settle for switching from one shaft to the other for now, and go from there. But yeah, I'll just show you this square wave again, but slowly. So I'll put the squeezing the trigger slightly. You just end up running out of there. I meant to say it was a 9 litre tank in these previous videos, but it's not a 25 litre tank. It delivers 25 litres per minute at 0 bar, it says on the sticker, and 18 litres a minute at 8 bar. Wow, it's only a baby anyway, but goes to show you that you don't need a massive compressor to reach over 300 miles an hour. You do need air storage though to keep going, and yeah, why not take that air storage from the environment rather than from a tank? The tank's just a starter motor, that's all it is. So yeah, so the plan is to get the vacuum pump, the second axle, set up with a tachometer, and get an air cylinder with 232 bar, and yeah, start doing the tests using that, and see what we can get out of 6, 7, 8, 9, 10, all the way up to 16 bar. And if we haven't got supersonic by then, I'll be surprised, but I have come across a couple of 20 bar blowguns, but I haven't got more information on that yet. Worst case scenario is I'll make one. Won't be too difficult. I just need something that I can put up to the input and take away once it's reached the right speed, and go from there. Alright folks, catch you later.